Company featured. Welcome to this Stockbox interview. Phil Thomas, the CEO of AIS Resources, joins us today to talk about the updated structural geology at their Fosterville-Toolleen project, and also to give us an update on the Incahuasi project with Spey Resources. So hello, Phil. Welcome again onto Stockbox. How are you?
Thank you very much, Mark. I'm very well.
Good. Well, thank you very much for your time. So there has been some significant updates, hasn't there, at the Fosterville-Toolleen project? So you've got some slides that you'd like to show me, and we can talk through them. So over to you.
Okay, thank you very much. As you know, we have 3 advanced gold projects in Australia, and we're partnering Spey Resources in their exploration program for drilling for lithium in northern Argentina. So going through the usual disclaimer, everyone's speed read that. So this is a map of where we have our current gold exploration permits in Victoria, and we have one in New South Wales. So the pink area there is near the Fosterville-Toolleen area. You can see the big Bendigo gold areas down to Dalesford, and then over here at our Kingston project near Ararat and north of the Stall gold mine, which sits over there. If we have a look at the size of the areas, we've got 167 square kilometres at Kingston, we've got 28 square kilometres at Fosterville, and we've got 56 square kilometres basically in 2 areas, 2.8 and 56 at Yalgogran. If we go and look at Fosterville and its location, it's 12 kilometres away from the Fosterville mine and the Fosterville exploration. In the middle is Block 3, is 334 square kilometres, and that's up for auction at the moment. So everyone's waiting for that to be decided. And then we're over here on the Toolleen Angle Road and the Axedale-Toolleen Road with our little area there. And most of the exploration is north of the Axedale Road. So we're in this area here. If we go to the next slide, this is a Google Map picture, and you can see down here in the front area here, the Fosterville mine, and that's where we are there. And you can see the Toolleen Road there, and that's 10 kilometres from there to there. And there's the town of Bendigo over here.
Okay.
Here's a gravity survey. So we're looking at highs and lows of gravity in the rocks over here. And this was done by the Victorian government, and that's a very high level processed gravity survey. And where that line comes in, which is right on the edge of the Toolleen Angle Road, that's where we got the 510 ppm of antimony, which is one of the pathfinders. Arsenic is the other one. And you can see there was a gold shaft put down there. There was a couple up here as well, but predominantly the area hasn't been explored that particularly well. Over to the right there, you can see a couple of unnamed shafts as well. Over here, you can see all the mines that sit in the Fosterville exploration area, and of course the open pit up here and the underground ramp down in here with the Swan Swan mine, underground mine sitting in here. So when we did our first gravity survey, we got these blue lines, which we had to interpret, and you can see across the line our drilling program. So this is where the high bismuth was found, and you can see that drill hole there. To the left is the ppb of gold, and to the right is antimony, and you can see there, bang, it hits 510 with 16 ppb of gold. And these values are exceptionally low. 510 ppm of antimony is quite exceptionally high, as is 65, as is 15 and 14. But we're basically looking for pathfinders here, and if we can see some gold, then that's even better. But we're really looking to define the structure and define what's going on there. So we looked at all these faults and basically thought, there's something going on this way and there's something going on this way, but we weren't too sure where it was. So we decided to get all this gravity data, which created this map, and have it reprocessed using some fairly sophisticated technology. And that's what I'm going to take you through today.
Okay.
So the first one was we had to take away the background gravity so we could see or highlight the areas that are high and low. And denser rocks have higher gravity, and less dense rocks have lower gravity. So what we can do is we can measure that, and all those pink dotted lines going along here are the gravity survey lines. And you can see they were quite closely spaced here. And further down the track, we're going to infill these lines in here so that we've got some better data in here, because the computer, to some degree, is dreaming a little bit where it runs out of data. So we're going to use the Sharp index, and this is what this relativity index. So we're creating an index, and the gravity is measured in megagauss. And so what we'll be doing is analysing this very, very closely. Or what we've done is analysed it very closely, and you can see very sharp contrasts here, some sharp contrasts here. There's a very sharp contrast going along here, and there's some big contrasts down here. So if we go to the next technique that we used, which is called multi-scale edge detection, over here on the left-hand side, you can see the depths of the gravity. So the blue dots are 200 metres, orange is 100 metres, and white is 25 metres, and infilled with cyan and red. So it shows a pattern very, very closely here of a long structure going this way. There's another structure coming this way, another structure coming this way. But in fact, if you look at the colours, the contrast and distance between white and black is quite close here. And likewise over here, and over here, and over here. There's something going on in here. And there's also something going on over here. Now, we know that these dots here are following the Mount Pleasant Creek fault, so we know there's a major structure there. And typically the gold forms close by or near the hanging wall of a major fault. So to our right, we have the big Mount Williams fault. And then as that moved and reorientated the land, the Mount Crescent fault, Mount Pleasant Creek fault occurred, and then over here the Fosterville fault happened, and then in this side of the fault, which is called a hanging wall, we can see where mineralisation has come up, and this is a major trend. So we're looking for what we call secondary and tertiary faults from a major fault with big intersections, and lo and behold, if we look at this map here, we've got some pretty interesting crosses. So let's go to the next level of analysis, and we'll go to the Booger gravity analysis. And this is basically taking all that data that we had before and integrating it, and lo and behold, we get some drill targets. So we've got a big feature coming along here into the Mount, sorry, I'm going to go back, into the major fault area here. Into the Mount Pleasant Creek fault. So there's a big intersection in here, and one here, and one here. And then we've got those black and the vertical contacts, which are quite close. So there's an area of interest to drill in here and here. So in fact, we have 4 major targets without really going into any real deep analysis of looking what might be happening in this area here. The lines, the red lines that you can see here, are the dip direction. And one of the beauties of this work is it tells us what the angle is. So an anticline will be formed in here because it's dipping away and away there. So it's in the top of the anticline. This whole area is Ordovician age, which is around 425, 450 million years old. And these Ordovician rocks are called Turbidites, and they're from shales and sandstones forming very fine-grained or coarse-grained sands, forming in edges of marine environments, and where they transition is where we see faults. And obviously it's been uplifted up to 500 or 600 metres where this is at the moment, but we can see in some of the models, especially around some of these synclines, where the eye of the syncline or the eye of the anticline gets fractured through these faults and the mineralisation comes through. And typically this can happen at 3 or 4 or 5 different overlays. It's not done in one. Typically, it's not done in one event. So we're absolutely ecstatic at the fact that we've got well-defined targets. All those worm lines, the ones that are not really of significance, have been taken out, and we've got a much clearer pattern of where to go. So to prove it up as another anomaly or another approach, we're going to run some soil sampling. So you can just see the white dotted lines and that big structure through there. And then there's that other structure coming through here. There's the vertical contact. So I'll just go back again. So there's the vertical contact, and there's the vertical contact there. So we'll be running soil lines along here at very close spacing. In fact, we're doing it right at the moment. I think we're up to about the intersection of the highway at the moment. And we'll be analysing those soil samples to see whether there's evidence in the soils of those major faults that we're looking at here and here and here. So clearly our drill targets are going to be of keen interest, and we'll be going through those and probably making a cross to soil sample so we get a really good understanding of what's going on. Mm-hmm. Then what we're going to do is once we've got our soil sampling in, we've got our structural geology, we've got our 4 targets, we're then going to run a system called Ultrafine clay technology. And basically what we do is we sample the soils for ultrafine clays, and we take them out and then use an analytical technique to look at what's left in the fine sample component. And this was pioneered by Australia's leading scientific institution, CSIRO, and they have a particular way to help explorers analyse it. So we're looking forward to using that technique to back up our XRF analysis. So we'll have a really good idea of what's on the surface, a good understanding of the structural geology, so we can improve our drill targets and hopefully hit the mother lode. So that's the point of that exercise. Just so that you can see the number of faults. Here's the big Mount Williams fault coming through. Here's the Fosterville Gold fault, and here's all the little faults in our area. So probably this one here is the Creek fault and Pleasant Creek fault, and then these are the other faults that we can see. So we're in pretty good area in here in terms of being on the hanging wall of that major fault system. So now I'll stop there. Do you want me to go through anything, Mark?
Yes. Maybe you can go back a couple of slides just to that that very colourful slide we were looking at just a few seconds ago, because as I understand, a gravity survey then, that is using a piece of equipment on the surface that then is sending a signal down. Is that right?
Yeah, that's right. It's measuring the different. It's actually measuring the gravity, and then when we take out, wrong way. And then when we take out the background gravity, which was 2.2 grams per cubic centimetre, when we subtract that, we get the variations. And so here we've plotted in colour, so it's easy to see the variations in gravity.
Okay, and that is like height and depth, is it, of what's going on underneath the ground?
No. What you're looking at is you're looking at differentials of gravity. So while it looks like a mountainous terrain, it's actually highs and lows. So you've got to flatten all those what appear to be curves and say, well, these are the areas of the same density. So the differential in density means that there's a differential in rocks, but the land is dead flat. So so we're looking at differences in lithology, and we're looking at lines of movement, and we're looking for curves. We're looking for straight lines. We're looking for interruptions in those lines, because that's where the change, there is a big change in lithology. So the ideal one is right here, where you've got deep dark blue here and high red here. So clearly there's something going on here.
Yeah.
These rocks wouldn't be so much less dense than these.
So that was my next question. You're looking really for the contrast areas. Those are your telltale signs.
Exactly. And there's a big contrast along here. So that's our N1, N2.
Yeah, because you've got red versus blue there. You can I can see you can make a line as you should.
And then over here it's less pronounced, but it's consistent in a movement of a block. So along here we've got that fault system over there, and we already know that there's a fault because the river's following the fault over here. So we know that there's a fault right there, which is white to red. But the blue gives you a really good example or good inference that there's significant change has been going on here.
Okay.
And from the worm pattern, we know that these are quite small and curved. So it's quite prominent.
Okay, so it's change. It's change in rocks, then, isn't it? That's what we're looking at here. The change in density, and you're looking for the pattern, which then suggests that there is a fault. There is a fault there, and there's two different things going on. Is that right?
That's right. Yeah. There's and where you get an intersection of faults, clearly there are shear zones, which are basically just small faults which rub one block against another block and creates a powdery area, which is nice and soft for the solutions to go through and deposit gold.
And it's faults then. It's faults that's where the deposits will be found, is in fault lines.
Yeah, it's actually interesting that it's typically not found in the big major fault that goes through. Typically, it's 2 to 3 kilometres away, and that pattern persists almost right through the whole area up to Bendigo.
I see. Okay. And the next step then, as you say, is to actually take some soil sampling. That is making a borehole in the ground, is it, and analysing what might be in the soil.
That's right. Yeah, we just, soil sampling is quite cheap. We've got our own XRF gun, so we can analyse that very, very quickly. And we've got a piece of software called IOGAS, which is well known in the statistical world, and we use that to look for patterns over the 33 elements that the XRF gun can see. So we'll be correlating arsenic to lead, to zinc, to calcium, to all the elements that we can see with our gun. But arsenic and antimony are the two key ones. Lead and zinc are secondary ones to the gold values. And then we'll get the drill out and hopefully hit some big intersections.
Okay, yes, that it does make sense, and thank you for explaining that. Because when you look at that picture, your eye is drawn to the nice colours, and you think, oh, that's like confused with maybe a mag survey where that's like an anomaly. Yeah. But you've explained that very well. Where actually it's the difference between the two and that kind of contrast area, and you can see that kind of grey on the previous slide there quite clearly.
That's right.
So that makes sense. And it's interesting what you said as well about the deposit not necessarily being on the main fault, but on there's like associated faults, and that again brings me back to the Fosterville and the location there. So you're almost on the same sort of, you're working with the same geology, is that right? The same kind of idea that
it's the same age. It's all Ordovician. They're all turbidites. They're all shales and sandstones graduating. In fact, no, I don't have it, but there's a great picture of the open cut at Fosterville, and if you look at the rocks there and look at the Ordovician rocks that are here, they're identical. You've got this, but these systems are massive. They're hundreds of kilometres, not just 10. But the structural geology is the key driver, because that's where the solutions have come up. And if you can zoom in on where they are, and it took Fosterville nearly 15 years to figure out what was going on, and they were running an open cut up in the top of the project, but the mother lode was sitting down here, but no one had figured out what was going on. So their model adapted as they explored. And of course, 3 or 4 years ago, or 5 years ago, they found the mother lode in the Swan shaft. But we are pretty confident. We've sort of accelerated the whole process. So generally speaking, this is after 2 or 3 years. We've been doing it in basically 12 months. So I'm pretty excited about where we're going, and I'm just can't wait to get these 4 drill holes to see which way we go. And we may run drill holes along there using RC drilling or E-core drilling, but mostly RC drilling, and then get some diamond drill holes in some of these targets, and probably go down past 80 metres, because this side there's a bit of Permian cover, so you can't actually see the ore division, whereas it thins out over to this way towards the creek. So if you can walk through the creek here, and you can see the ore division in the surface.
Mm-hmm. And you've planned these drills to go where the 2 faults kind of intersect there, is that right?
Yeah. So one on this sort of, if there's sort of three majors fault zones that we've identified from this work. So that one, and that one. If we come back to this one, we can see here one, and then there's an intersection there. There's one over there with a big contrast, and there's one there. Mm-hmm. So that would be the four targets. This one's quite interesting, because you've got basically a big fault going this way. You've got one there, possibly some offset over here. So this is an area of interest, and you've got some fairly strong contrast between white and dark in here. You can almost see the line going through.
Mm-hmm. Okay, excellent. Okay, good. So then on to the soil sampling and, of course, the drill program then. When are you hoping to get them started?
Well, Australia closes down in January, which is our summer holidays. So we're hoping to get this done and started in December, but there are quite a bit of demand at the moment for drill rigs. So we basically are trying to book one in right now, thinking that we'll have this finished by the end of November, but we'll probably only get 2 weeks work in December, and then have to come back in the last week of January, because that's typically everyone has their time off for the last week of 2 weeks of December and the first 2 weeks of January. So, but that's a month. And our geologists take their summer holidays with the kids anyway, so that kind of works in fine.
But you'll be able to get the soil sampling at least completed and hopefully some results reported before the end of the year anyway.
Absolutely, yeah.
Okay, excellent. Okay, well, yes, I can understand your enthusiasm and probably itching to get those soil samples on the way and get seeing some results. So thank you for that. That's a good update. Okay, and you want to also update us on Incahuasi as well?
Yeah, I just thought I'd put a couple of slides in. We have a joint venture with Spey Resources, and we're the project manager. We've got a carried 20% equity interest, and they have a 1-year option to explore. And if we do a indicated resource is more than 45,000 tonnes of contained lithium metal, which is about 250,000 tonnes of lithium carbonate, they can pay us $6 million to buy us out, or we continue on with our equity interest. So as of yesterday, we had completed 3 50-metre holes with some exciting brines in one of those. And we've got 1 by 50 metres and 1 by 250 metres to go. You're seeing the excavator digging a sump hole, and you can see the brine coming straight to the surface. And so from a broad brush point of view, if we can get 25 litres per minute coming up, and you can see there's more than probably 25 litres a minute pumping into that hole that they've just dug, then we'll probably start putting in production wells. But we want to see what's in the 150 and the 250, because that surface brine is probably only 100 ppm, further down it should be 200 or 300. If we have a look at the hole, you can see that it's basically all, this is from 3 metres to 4 metres. It's all salt, and that salt will probably go down 50 metres, and then they'll start to get into the dark sands which have the aquifers. So this salt is very, very hard. It's actually quite incredible. So if we have a look at the drill rig, that's the rig there. There's the roads, which were an effort to put in, and so that was actually the first hole they put, and then they're basically going to go down the valley and around the corner. It's quite a big area, and from that sample there, we took the brine, sent it to Melbourne University, and we produced lithium carbonate using the EcoSolve process. And this was done from about 50 ppm of lithium in the surface brine. So we were delighted that we got something like a 90% recovery of the lithium, and that's a 99.6% lithium carbonate grade, which is what you'd expect because it was lithium chloride, and then we just added sodium carbonate and converted it to lithium carbonate. So it's going well. Good weather, as you can see, and we're looking forward to the results of these 2 drill holes here.
Okay, so continuing with drilling and the holes you're digging there to get some to see what you can find.
Absolutely, yeah.
Okay, good. Well, thank you very much, Phil Thomas, the CEO of AIS Resources, for giving us that update today.
A pleasure.
Thank you for listening to this Stockbox interview. For more information, interviews and videos, visit our website at stockboxmedia.com or give us a follow on Twitter by searching @StockboxMedia.